Don't chase marks. Let the marks chase you. You want to understand. You want to learn. And if you want all those tips and tricks to get you full marks in physics, chemistry, and maths, then this channel is just for you. So subscribe, like, share, and comment as you watch this video till the end. Let's now get to the business of earning marks. Mensuration circles is yet another topic in the study of planar figures or 2D figures. And I have already uploaded the video of mensuration in the triangles and quadrilaterals. The link is in the description box. These topics are extremely important for senior school of all the boards. So let us start with the basic concept and then go slowly over the complex questions. So what is a circle? Let us take a fixed point. This is the fixed point. Let us call this as O. And let us take another point, this one, and that is A. Let us call OA as R centimeters. And now let us move this point A in such a way that it is always R centimeters from O. So let us say we have this point here, this point here, this point here, this point here. So A is traveling at always a constant distance from this point, fixed point O. Now, if you join this, you will get the path of point A, which is always at a fixed distance from O. Now, this path, that becomes the circumference of this circle, and the figure that we obtain, which is consisting of the circumference and the part within that, this is called as the circle. So a circle is obtained when a point moves at a definite distance from the given fixed point. The given fixed point is the center, and the definite distance which it is moving at, that is the radius. I have represented it with the letter R. So the terms involved will be the center, which is this fixed point. The radius is the distance between the center and any point on the circumference. The circumference is the boundary of the circle or the perimeter of the circle, which means you start from a point, go right round and come back to the original position. The path that you have traveled, this one is the circumference. Now, if we take two endpoints on the circle such that the line segment joining the 2 points passes through the center, then this distance becomes the diameter. So we come to the next term, which is diameter. If you take any 2 points on the circumference and you join them, then what you get is the chord. So you see that even a diameter is the distance joining the 2 points on the circumference, and so diameter also is a chord, but it is the longest chord. If we take any 2 points over here, we are going to get the chord which will not be as long as the diameter. So what do we see? Diameter, and the diameter is the longest chord. So if we asked about the longest chord, remember it is the diameter. So now we come to some more terms. A chord divides the circle into 2 parts. So we have this part and we have this part. Now these 2 parts, this yellow and this green, they are called as the segments. So what is a segment? The segment is the portion of the circle which is between the circumference and the chord. So we are coming to another term which is the segment. Also understand that the segment here, green one, and this yellow one, that is the total surface which is within the boundary or within the circumference of this circle, and this will be the area of the circle. If the segment is less than half the circle, then it is called as the minor segment. And if this segment is more or greater than the semicircle, like this green part is more than half the circle, then it is called as the major segment. Of course, if we take half the circle, that is called as the semicircle. And if we take the quarter circle, that is also called as the quadrant. So now you know semicircle, you know the quadrant or the quarter circle. If we take any 2 points on this circumference, let us call this as point A and point B. So this portion becomes the arc. So what is the arc? The arc is the part of the circumference. The end points of the arc can be joined to the center of the circle, and if we do that, we will get the area of the circle, which is like the part of the circle which actually looks like a pizza or the cake slice, right? Okay, now this portion is the sector. So what is a sector? Sector is the area of the circle which is bounded by the two radii and the arc of the circle. Now that we've understood the basic concepts, the most important thing, that is tip number 1, is to know the formulas by heart. So if we have area of the circle, it is pi r square. If it is area of the semicircle, semi means half, so it becomes half of pi r square, that is pi r square upon 2. Got it? Third one, area of quadrant. What is a quadrant? It's the quarter circle. So it will be quarter of pi r square. So it becomes pi r square upon 4. Now area of sector. What is a sector? If we have a circle, these are the two radii and this is the arc, this is the sector. Now this is having the two radii from the end points of the arc making an angle of, let us say, theta degrees. So the area of this sector will be a fraction of this whole circle. So it will be fraction of pi r square. How much of a fraction? It will be theta upon the whole thing from here to here. How much is that? 360 degrees. So area of sector becomes theta upon 360 degrees multiplied by pi r square. Next we come to circumference. Circumference is the perimeter of the circle. It is 2 pi r. Everywhere, can you see we are writing pi, 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 pi. How much is pi? 22 upon 7 or 3.14. Circumference of the semicircle will be half of this. So the arc will be, the arc of the semicircle is going to be half of 2 pi r, means it is pi r. And plus we have to add this and this. So if we go right round like so and like so, come back. So we travel the arc of the semicircle and plus this boundary, this is r, and r means it is diameter, and so we say it is pi r plus d. Now even if you don't remember this formula, it's fine. You just draw the diagram and go right round. Okay, so circumference of a quadrant, the same thing. You are going to take the arc of the quadrant. Let me just show it here. A quadrant, I will show like this. This is 90 degrees. So the arc of this quadrant will be this portion. This portion will be 1/4 of the circumference. That will be 2 pi r upon 4. That will give you pi r upon 2. So pi r upon 2 plus this radius plus this radius. So that is where we get pi r upon 2 plus 2r. Got that? Now, that is the first and the most important thing. You have to know your formulas. You don't know your formulas, you are going to find it very difficult to solve the problems or questions or numericals based on this. Okay, so now that we learned this tip number 1, let us see how to apply. So now we'll come to tip number 2, 3, etc., etc. Okay, so we understood tip number 1. We have to know these formulas by heart. The first question that we have is this one. Now, as you can see, I have taken the question papers, and from the question papers, I have taken selected questions which are pertaining to our topic for today. What is our topic for today? Mensuration in circles. Now, you will not be given directly a circle and straight, nobody is going to ask you, find the area of the circle. Radius is, let us say, 5 centimeters, and then you say area is equal to pi r square. So you'll say 22 upon 7 multiplied by 5 into 5. Nobody is going to ask you direct questions like that. It will always be in combination with the other planar figures. Now in this you can see there is a quarter circle. Can you see this? This is given as 90 degrees here. And then you will see there is a triangle, and you are expected to find the area of the shaded region. Look at that. In the adjoining figure, triangular piece OAD is removed from the piece of cardboard, shaped like a quadrant of a circle with center O. So we see this is a quadrant, and from that this piece is cut out. Alright. So radius is 7 centimeters. So radius of from here to here, it is 7 centimeters. OA is 3 centimeters. OD is 4 centimeters. Find the area of the remaining part. The remaining part is going to be the shaded part, and then the perimeter of the remaining part. So when we have a question like this, the first thing that we do is you draw the diagram for yourself in the paper. So we'll do just that. To draw the diagram and to write the data that is given from the question is the most important part, and that is your tip number 2. What was our tip number 1? To know the formulas. Very good. Tip number 2, draw the diagram according to the question, according to the problem, and we are going to write OD as 4 centimeters as given in the question. OA is 3 centimeters. The radius is from the center up to any point on the circumference. So OB as well as OC is 7 centimeters here, 7 centimeters here. Are you with me? Okay. Now the remaining part is the shaded part, for which we have to find the area. Now the area is going to be area of the quadrant minus the area of the triangle, right? Can you see that? From here, this part is taken out. Alright, so we are going to first find the area of the triangle. So in our solution, we will write area triangle DOA. You remember the formula for the triangle? The area is half base into height. So half into OA multiplied by height, which is OD. That gives us half into 3 into 4. That will give us 6 centimeters square. Everybody's clear with this? Alright. Now, area of the quadrant. What is our formula for area of quadrant? Let us write it here. Area quadrant. What does a quadrant mean? Isn't it the quarter circle? So it is going to be 1/4 pi r square. Shall we substitute? 1/4 multiplied by 22 upon 7 multiplied by how much is our radius? So we write r square means 7 into 7. And that will give us 11 into 7, which is 77 upon 2, which is equal to 236, 2 8 16, and 0.5, those many centimeters square. And so what we will say is that the area of remaining part is going to be area quadrant minus area triangle, correct? And that is going to give us area of quadrant is 38.5 centimeters square minus 6 centimeters square. That gives us 32.5 centimeters square, and that is our Answer 1. Did we get that? All right, that is fine. Now let us come to the second part. The second part talks about finding the perimeter of the remaining part. Now look very carefully. The remaining part is DA plus AB plus the arc BC plus DC. So to begin with, we will have to find out this part from here to here. How will we find this? Using Pythagoras theorem. Do we know Pythagoras theorem? Right. So use the Pytho theorem. You know how much is going to be? It's going to be 5 centimeters, right? So we are writing here 5. Now tell me, how much is AB? Isn't AB OB minus OA? This full thing is 7. 3 centimeters gone. So from here to here we will have 4 centimeters, correct? Then out here DC we can also find the same way. This full thing is 7 minus 4. That gives us, right? You're understanding, right? Now all we have to do is find this arc. So let us see how we write the steps. I have shown the steps here to find AD square using Pythagoras theorem, like so. You already know the Pythagoras theorem. Now we come to finding the arc BC. Arc BC will be 1/4 of the total circumference. The total circumference is 2 pi r. So it becomes half pi r. That is half into pi value is 22/7. All of you know that. Multiplied by 7. And so we have cancellation giving us 11 centimeter as the value of AC. Now our question is find the perimeter of the remaining part. The perimeter is going to be equal to, I will take AB plus I will say arc BC, like so. Then we'll have CD and then we will have DA. So the lengths of these are given as AB, can you see, 4 centimeter, plus arc BC is 11, plus CD is 3, and plus DA is 5. And so you will see this is 20 and 3, 23 centimeter. Did we understand this? Was it easy? Let's take another question. In the adjoining figure, OABC is a square. It is inscribed in a quadrant OPBQ of the circle and AO is 14 centimeter. Find the area of the shaded region. Take pi as 22/7. What was our tip number 1? Know the formulas. Tip number 2 is to draw the diagram and write the details. So we will do just that. So our tip number 1, to draw the diagram and fill up all the data. OA was given as 14 and this was given as square. So I have put 90 here. Here also I should be putting 90 degrees here. Okay, this is 14, this is 14, this is 14, this is 14. Are you clear? Now, if I want the shaded area will be area of the quadrant, but I need to know the radius. So now we start applying the knowledge between the known and the unknown. So that is your tip number 3. So we connect the known facts with the unknown fact. Now, what is the radius? Radius is any point on the circumference and the center, which means I need to connect O with B, and that will give us a radius. Now, what is the connection between this radius and the triangle that is formed over here? Can you see this is 90 degrees? So what type of triangle is it? It is, that's right, this is a right triangle. So what should we do? We should say in right triangle OAB by Pythagoras theorem, I'll just write PT, and we will have hypotenuse means opposite 90 degrees is hypotenuse. So OB squared is equal to OA squared plus AB squared, correct? Now, OA squared will be 14 square plus 14 square. That gives us 2 multiplied by 14 square. So OB is going to be under root of that. So that will be under root 2 multiplied by 14. So we will simply write it over here, 14 root 2 centimeter. But OB is the radius. So we write radius here, and here also we will write 14 root 2 centimeter. So we understood how to use tip number 3. Now once you got this, see they have not given you radius directly, but they have told you that this is a square. So you got to understand that if you take any point on the circumference and connect it with the center, you will get the radius. Our first problem is solved now. So let us look at the quadrant and the area. Area quadrant. Know your formulas, I had told you. So it will be 1/4 multiplied by, very good. You got that? Okay. Now 1/4 multiplied by, what is the value of pi? 22 upon 7. Very good. Now what is the value of r? We just found it. Can we see that? Now I'm giving you time. Solve this. Check your steps. So you have substituted pi as 22 upon 7, radius as 14 root 2 into 14 root 2. Let us do the cancellation. 7 ones, 7 twos, and then 2 ones and 2 twos, and 2 goes here 11 times. So 11 into 14 into root 2 into root 2. Got that? Alright. So 11 into 14 gives us 154. Root 2 into root 2 gives us 2. So when you multiply by 2, you will get 308 centimeter square. What is this? This is the area of the quadrant. Now if I want shaded area, shouldn't I remove the area of the square from there? So we will be writing area square. And what is our formula? Side square, correct. So that is giving us side square equal to 14 square, which is 256, correct, centimeter square. And then we'll have shaded area equal to area quadrant minus area square. And so it is 308 minus 256, correct? And that will give us 52 centimeter square, and that is our answer. Are we getting this? How many of you got this without me showing this to you? Give yourself a star. Our question 3 reads, PQRS is a square piece of land of side 56 meters. So we have a square piece of land, 2 semicircular grass covered lawns. So you can see these grass covered lawns are made on 2 of its opposite sides as shown in the figure. Calculate the area of the uncovered portion. Now remember, tip number 1 is to know all your formulas by heart. Tip number 2 is to draw the diagram, and you have to show the data that has been supplied. Let's do that. So in our question number 3, we have used our tip number 2, and we have drawn the diagram, and we have put all the data that had to be written here. 56 meter was the side of the square. Then we have the semicircles, which means the full thing from here to here is 56, and therefore each one of these become the radii, and each radius is going to be equal to 56 upon 2, which is 28 meter. And also we know that these semicircular regions, what are they? They are the lawns. And they are asking us find the area of the uncovered portion. The uncovered portion, I have shown it in yellow. Now, why did I use these colors? Because it gives me clarity of thoughts. Okay, so extremely important is to know what you have to find, and that is your tip number 2. Tip number 3 is to understand and recognize which other formulas to be used. What are the figures over there? So we have a semicircle here, we have a semicircle here. So do we know the formulas for semicircle? Yes. Can we see this whole area is the area of the square? Yes. So this yellow part, that is uncovered portion, will be area of the square minus the area of the two semicircles. So shall we write just that? So we have area square is going to be equal to side square, which means it is 56 square. Now, do we know how to use the formula a square plus 2ab plus b squared to find the square of a two-digit number? Go through my series quick calculations. I'll put the link in the description box so you can have a look at those shortcuts. So we have 6 36, carry 3, 6 5 30, and 2 is 60. So we have 63, and then we have 5 5 is 25, and we have carried over 6, that is 3136. Those many meters square. Now we have to find the blue area, that is area of the semicircles. So we write area of semicircle. Remember the formula, it will be half multiplied by pi r square. Therefore, area of two semicircles will be 2 multiplied by half into pi r square. Getting it? That will give us pi means 22 upon 7. And how much is the radius? Can you see the radius we have written over here? 28 times 28. And so you have 7 ones and 7 fours. So you have 88 multiplied by 28. Got that? Let's show the working. 88 is multiplying 28. So we will have 8 8 64, carry 2, 8 2 16 and 2 18. Two zero two four. So that is 2024 meter square. Therefore, area uncovered portion. Which portion? Uncovered portion will be equal to area of square minus area of two semicircles. Can we see how nicely and neatly we have to write? Now we substitute the values. And that is our answer. Are we understanding this? Shall we take another question now? Let's look at question number 4, which again I have taken from another paper. In the adjoining figure, ABCD is a square. Can you see this? ABCD is a square. And points A, B, C, D are the centers of the quadrants of circles of same radius. So can you see? This is a quadrant and A is the center of that. B is the center of this quadrant. C is the center of this quadrant. And D is the center of this quadrant. Are we getting it? All right. If the area of the shaded portion is 36 upon 7 centimeters square, find the length of the boundary of the shaded portion. Take pi equal to 22 upon 7. What was our tip number 1? Know all the formulas by heart. Tip number 2, draw the diagram. Write all the data in it. So let's just do that. So we have drawn the diagram. Now we are told that ABCD is a square. So we know that each one of these sides are going to be equal. But they have given us area of the shaded portion. They have not given us the radius. They have not given us even the side of the square. And so what we have to do is connect. This is your next tip. Connect what is known with what is unknown. What do I need to do? I need to find the length of the boundary of the shaded portion. So I have shown the boundaries with this green. If I have to find the boundaries, I must know the radius of each of these quadrants. From here to here, the radius should be known. But I have no clue about how to go about. So simply, I'm going to concentrate on the shaded area. Now, the shaded area is the area of square minus take out this quadrant, this quadrant, this quadrant, this quadrant, which means the area of the square minus the area of 4 quadrants, right? So now let us write just that. So I need to find out area of square, I need to find area of quadrant, but I'm just going to write this as R, and so from here to here, it becomes R plus R, which means it is 2R. Are you with me? So area of square, each side becomes 2R. So it becomes side square means 2R square. That becomes 4R square. Area of the quadrant. Area of the quadrant is 1/4 multiplied by 22 upon 7 multiplied by R into R, that is R square. And therefore area of 4 quadrants. Won't that be 4 multiplied by 1/4 into 22 upon 7 into R square? We write this quantity out here. 4 gets cancelled and what we will get is 22 upon 7 R squared. Got that? Now connect this and this with this. Tell me, how will you connect it? Isn't area of square minus area of 4 quadrants the shaded area? So we write just that. Now area of square we already found out, area of 4 quadrants we found out. Now I want you to substitute here these values and I want you to substitute this value and I want you to write down the calculations giving you time now. Check your steps. Shaded area was this. Area of square is this. Area of 4 quadrants is this. Take LCM here. 7 is the LCM. 28R square minus 22R square. 7 and 7 from both sides gets cancelled. 216 is equal to 6R square. R square will be 216 upon 6. 6 will go here. 36 times R will be equal to under root 36, which is 6 centimeters. Did you get that? Come on, collect your star. Give yourself a nice star. Now this is where we got the radius. Now let us look at our diagram. Our diagram is here. How do I get the boundary? I need the arc of this quadrant, this quadrant, this quadrant, this quadrant. Isn't this part of the circumference? Yes. Okay, so we will find the arc of each quadrant. It will be 1/4 of 2 pi r and then we will take 4 of them together. That will give us the 4 arcs and that will be our boundary. Okay, let us see how we proceed with that. So arc of a quadrant is 1/4 into 2 pi r, which is the formula for the circumference. So the total arcs of 4 quadrants will be 4 times this. Can you see how I multiplied by 4 this particular quantity? Okay, so 4 gets cancelled and you have 2 pi r. Pi is 22 upon 7 and radius we got it as 6. Okay, so we have this and we have 264 upon 7. That gives us 37.71 centimeter and that is our answer. Now we come to the last question of this video. If the circumference of two circles be 396 centimeter and 374 centimeter, find the area of the shaded portion. Now you tell me, children, if it is 396 centimeter, won't it be the circumference of the bigger circle? And 374 centimeter, won't it be the circumference of the smaller circle? So now we are going to follow all the tips. What was our first tip? Know your formulas well. You know them well, you must know them well. Point number 2, that is tip number 2, draw the diagram and connect it with what is supplied and what is to be found out. Tip number 3, apply the formulas with what has been supplied to what has been asked. So we do just that. So we have done just that. We have the outer circle. Circumference is 396 centimeter square. I call it as C1. And so if I know my formulas well, I will call that as 2 pi R1. The inner circle has the circumference given as 374. And so I will write it as 2 pi R2. What is our area of shaded portion? It is the outer area minus the inner area. What is our formula for area? Isn't it pi r square? So we'll call that as pi r1 square minus pi r2 square. Which means it is pi into bracket r1 square minus r2 square. You're with me so far? Okay, so now let us see how we proceed from here. We have written outer circumference as it is given 396 centimeter, and I have made a column and I have written this side. Simultaneously we'll do this. Inner circumference is 374 centimeter. Can you see that? You're understanding. And you want to learn how to do this fast. So outer circumference will be 2 pi r1. Inner circumference will be 2 pi r2. And we write it like so. Now what you're going to do is you're going to substitute the value of pi and you are going to find the value of r1 and r2 starting now. Check your steps. You got this as 63. Check your steps here. You got that? Fine. Give yourself a nice good star. What are we to find? We have to find the area of shaded portion. And so we are going to say area of shaded portion is equal to pi into bracket r1 square minus r2 square, which is going to be equal to, what is the value of pi? 22 upon 7. Now r1 square, 63 square, it's easy to find. But here it's going to be a headache. So what we have to do is, we have to do r1 plus r2 into r1 minus r2. What did we use for this? Didn't we use a square minus b square is equal to a plus b into a minus b? Are we getting it? Are we understanding? I told you, you will love to understand and do this work. If it is explained nicely, anybody can understand and do the work correctly. So we are substituting like so. Got that? And that is going to be equal to 22 upon 7. So we write 122.5, and here we will write 63 minus this, that will be 3.5. You got that? Now let us see how we proceed. 22 upon 7 multiplied by 1225 upon 10. I'm removing the decimal, and here 35 upon 10, and that gives us 7 ones, 7 fives, 5 ones, 5 twos, 2 ones, 2 11s, and so we are going to have 11 into 1225 upon 10. Now, remember how to get multiple of 11? I have my videos on quick calculations. You can refer to all the shortcuts to get 11 times multiple. I won't waste time on this. So we have, that is how we get the multiples. And then we will have this 1347.5 centimeters square, and that is our answer. I will put the link to multiplication by 11 in the description box for you for your ready reference. So we have come to the end of the video. Now tip number 4 and the last tip is practice. Nothing can be achieved if we do not practice it. So practice is so very important. I have put some links in the description box for some of the textbooks that you can refer to. So now tell me, did you find this video helpful? How many stars did you get? Write it in the comment box. Till I see you next time, thank you for watching. For more information on the concepts of maths, physics and chemistry, subscribe to my channel and click on the notification bell so you will be updated whenever I upload a new video, and enjoy learning the easy way.